guys, welcome back to Wong Chemistry channel. For this video, we'll discuss about 4.3, the part 4 of this subtopic. Part 4 of this subtopic, we'll be talking about orbital overlapping. So we are basically going to draw the orbital overlapping. Alright, so we are going to have a lot of drawing. Make sure you have your pencil and paper ready with you. But before we go into your orbital overlapping, you still need to know the hybridization of the central atom first. Therefore, let's recall on how to determine the hybridization of your central atom. The step 1 is definitely the correct Lewis structure. You must have your correct Lewis structure. From the correct Lewis structure, you can determine the electron domain. The electron domain of the central atom will be determined by using the formula sigma plus lone pair. Alright, I hope you still remember this. From the electron domain, you then can identify the type of hybridization of the central atom. All this is something that you have learned in previous video. Make sure you have watched the previous part of the video before you stepping into here. Alright? Because I won't be explaining all this step anymore in this video. After the type of hybridization, you then can draw the orbital overlapping that we are going to discuss in this video. I will going to show you how to draw the orbital overlapping from the type of hybridization and the correct Lewis structure. Okay? So, after you have your correct Lewis structure, knowing your electron domain and also the hybridized orbital, you then need to know the geometry. Okay? So, by that in mind, your linear shall look something like this. That is how your linear look like. When you have your electron domain 3, your hybridized orbital sp2, which is a trigonal planar, your trigonal planar shall look something like this. I hope you remember the geometry of each and every one of them. When you have a sp3, which is a tetrahedral, your tetrahedral shall look something like this. Alright, that is your tetrahedral. Your trigonal bipyramidal, when it's a sp3d. Trigonal bipyramidal, easy. Okay, make sure you know how a trigonal bipyramidal should look like. That is how your trigonal bipyramidal look like. Last but not least, when you are having your sp3d2, we are going to have octahedral. So, the shape of octahedral or the shape of your sp3d2 shall arrange in the octahedral geometry. So, make sure you know how your octahedral look like. Okay? Since it's a drawing of orbital overlapping, guys, we'll be using this a lot. We'll be using all the shape a lot. Okay? So, the most important question of this video will be, how can I draw the orbital overlapping? What is the step in drawing orbital overlapping? The step 1 is definitely identify the hybridized orbital. You must know the type of hybridization of your central atom from your correct Lewis structure. Remember just now? Correct Lewis structure, electron domain, hybridized orbital, and also the geometry. Okay? After you identify the hybridized orbital, you are then going to identify the geometry of the hybridized orbital. And you are going to draw it in the correct geometry and make sure you label the correct geometry. Next, you are going to overlap your central hybridized orbital with the orbital of the terminal atom. So you have your center already. Right now, you are going to overlap the central atom with the terminal atom. As always, we are going to draw and label. Okay? Alright? Simple. That is how we are going to draw the orbital overlapping. So make sure your step 1 still getting the correct Lewis structure, getting the correct electron domain, and identify the hybridized orbital before you can move into orbital overlapping. So, talking about orbital overlapping, we have two different orbital overlapping. One is your end-to-end overlapping. I hope you remember that your end-to-end overlapping is for the sigma bond. And we have three different end-to-end overlapping. You can have your s orbital overlap with your s orbital forming a sigma, end-to-end overlapping, or you can have your s orbital overlap end-to-end with the p orbital to form another sigma. Last but not least, another sigma bond that can be formed is from your p orbital overlap with the p orbital head to head, end to end, to form a sigma bond. So to form a sigma bond, it must be an end-to-end overlapping. Alright? Next, we have a pi bond. Alright? Pi bond means it must be a sideway overlapping. Sideway overlapping, guys. So the sideway overlapping over here will then produce you a pi bond between p orbital and p orbital. But for this video, we'll focus on your sigma bond first. Alright? Your pi bond will be in the other videos. So first example, let's start off with your beryllium fluoride, BeF2. Okay? So as always, we will start off the first step with the total valence electron to draw the correct Lewis structure. I won't be explaining the Lewis structure already. Make sure you know how to draw a correct Lewis structure. If you don't, make sure you check out the others video. We have a video in this playlist talking only about drawing Lewis structure. Make sure you check that out. After you draw your correct Lewis structure from the total valence electron, next we are going to determine the electron domain. From this calculated electron domain that you have determined, then you can go for the type of hybridization and the geometry of the hybridization. Just a kind reminder, all your electron domain and your type of hybridization and the geometry will be based only on the central atom. Okay? So we are only looking at the hybridization of the central atom. So now, you already have the type of hybridization and the geometry, knowing that your beryllium having sp hybridized orbital in the shape of linear. So right now, let's go for the orbital overlapping. So how do we draw the orbital overlapping for your BeF2? Okay, we will start off for the central atom in the shape of linear for your sp hybridized orbital. So your sp hybridized orbital shall look something like this in the shape of linear. Before you proceed, make sure you label it. That is for my Be, that is my sp hybridized orbital. Okay, so first thing that you do, draw the central atom hybridized orbital in the correct geometry. Next, looking at your Lewis structure, you know that your terminal atom is a fluorine. And the valence electron of fluorine is located in 2p orbital. So we are going to draw a 2p orbital and overlap the 2p orbital with the sp hybridized orbital to form this sigma bond. So first one, let's draw a p orbital. Okay, so that is my 2p orbital of my fluorine. Alright, label it. But we are not done labeling. We have an overlapping area over here. What is in the overlapping area? The overlapping area, you're having a 2 electron with opposite spin. And the 2 electron of opposite spin over here represent the sigma bond that you have in the Lewis structure. Make sense? That is your orbital overlapping, where your sp hybridized orbital overlap end to end with the 2p orbital to form a sigma bond. Alright? Next, you have another sigma on the left. Therefore, you need another 2p orbital to overlap with the sp hybridized orbital of the beryllium. So you have a 2p orbital over here. And this 2p orbital belongs to fluorine. Make sure you label that. Alright? Make sure you label that. And then in the overlap area, you have 2 electrons in a pair with opposite spin. And that is your another sigma. See that? This is what we call orbital overlapping. So your orbital overlapping must be in the correct geometry. Overlapping in the correct method. When it's an end-to-end overlapping, make sure it's an end-to-end overlapping. And last but not least, other than drawing your orbital overlapping, you must also label everything. When you are done drawing the central atom, you label the central atom. When you're done drawing the first sigma bond, you label the first sigma bond. When you're done drawing the second sigma bond, you label the second sigma bond. Okay? Then everything will be clear and simple. Easy? If my drawing is not clear enough for you, you can refer to this. It's exactly the same as what I have drawn. So you have your beryllium fluoride in your Lewis structure with all the lone pair. Okay? So you can see that your beryllium right now is actually a sp hybridized orbital. sp hybridized orbital. Overlap end to end with the 2p orbital of fluorine, forming a sigma. Can you see that? So the same thing happened to the both left and right because I'm having another sigma on the right. So to form this sigma, your sp hybridized orbital will overlap head to head, end to end, with a 2p orbital of the fluorine. Okay, from the 2p orbital of the fluorine forming a sigma bond. Easy. That is your first example of orbital overlapping. Alright, let's try another example, BCl3, boron trichloride. So as always guys, let's start off with a total valence electron and correct Lewis structure. From the correct Lewis structure, you then can work out the electron domain. From the electron domain that you have calculated, then you can move on to the type of hybridization and the geometry of the hybridization for the central atom. So right now, you have the correct Lewis structure. Determine the electron domain, which is 3. From there, the type of hybridization determined is sp2. And the geometry is trigonal planar. Bear that in mind, trigonal planar looks something like this. So next, we'll be going into your orbital overlapping. So we are going to draw the orbital overlapping once again. But right now, the geometry is different because the hybridization is different. Okay? So let's start off with your central atom boron. Your boron central atom is an sp2 in the shape of trigonal planar. So let's start with a trigonal planar. Okay? Don't forget to label them. The central atom is boron. The type of hybridization is sp2. Make sure you label them before you move on to the next step. Okay? So once you have your central atom, boron, label, and then you have your sp2 hybridized orbital in the correct shape of trigonal planar, you then can overlap it with the terminal atom to form your sigma bond over here. The valence electron of chlorine is located in 3p orbital. Therefore, to form the sigma bond, your sp hybridized orbital will be overlapping with a 3p orbital to form a sigma bond with your chlorine. Therefore, let's draw a 3p orbital. So that is my 3p, and this 3p belong to chlorine. Okay? And we are not done yet. We have an overlap area. Can you see there is an overlap area? And in this overlap area, you have 2 electrons in an opposite spin, which is your sigma bond. Your first sigma bond. See that? And look at my drawing right now. They are end-to-end overlapping. So the same thing over here, to form another sigma with the chlorine on the left hand side, you still need another p orbital, and the p orbital must overlap end to end. Bear that in mind, there must be a line. There must be 180 degree aligned. So when you draw your p orbital must be 180 degree with the sp. Can you see that? Alright, that is your 3p orbital from the chlorine. Okay? And don't forget your overlapping area having 2 electrons over here with a sigma bond. Simple. Alright, simple. Next, the same thing, it must be overlapped parallel with the sp hybridized orbital. So make sure your p orbital right now is parallel to your sp orbital. And this 3p orbital is coming from chlorine. Okay? And in the overlap area, there is 2 opposite spin electrons that form your sigma bond. Easy. See that? I hope right now you roughly know what to draw and how to label your orbital overlapping. Make sure your drawing is big enough, neat enough, and also clean and clear to get all the marks that you need in the exam. Alright? And that is our orbital overlapping. And a better version of it, of course, by using the computer, you have your sp2 hybridized orbital in the shape of your trigonal planar of the boron. will overlap end to end with the 3p orbital of the chlorine, forming one sigma bond. Same thing over here, sp hybridized orbital overlap end to end with the 3p from the chlorine, forming another sigma. Okay, so make sure you have all the label clean and clear on your orbital overlapping diagram. Easy. Alright. Next example, CH4. Let's start off with the Lewis structure and all the way to the geometry of the hybridized orbital. So, we are done all the way from your Lewis structure to your electron domain. Knowing the electron domain, getting a hybridization of your CH4 is a sp3. Knowing that your sp3 will be the geometry of tetrahedral. So, kind reminder, tetrahedral looks something like this. So, when you draw your sp3 hybridized orbital, it must be arranged in the shape of tetrahedral. So let's straight away move into the orbital overlapping of your CH4. Okay, so we will start off with the central atom carbon, which having electron domain of 4, type of hybridization sp3 and in the shape of tetrahedral. So let's draw the tetrahedral first. Make sure all your orbitals, make sure all your lobes is a similar size. Okay, because they are all sp3. Since they are all sp3, all of them should have a similar size. Okay, forgive my bad drawing. I'm sorry, guys. So that is my carbon over here, that in the shape of tetrahedral in the hybridization of sp3. Okay, and right now, your carbon central atom will be overlapped with the s orbital, 1s of the hydrogen to form sigma bond. So everybody knows that the electron of the hydrogen is located in 1s orbital, which is a sphere. Your 1s look like this. So right now we are going to overlap your sp3 hybridized orbital with the s orbital from the hydrogen. So you basically just draw a sphere. And this sphere is actually the 1s from the hydrogen. Simple. And of course, in every overlapping, you will produce a shared region. And in the shared region, you will have 2 electrons with opposite spin, which is your sigma bond. Simple. Alright? Easy. Very easy. All this is very easy as long as you practice. Picking up your pen and start drawing. Then your drawing will be nice, clean and easy. Okay? So in the shared region, again, you have your sigma bond. Another s orbital overlap with the sp hybridized orbital because the s orbital coming from the hydrogen. So you have your sigma bond that form in between the sp hybridized orbital and the 1s orbital from the H. As always, in the overlap region, you have a pair of electrons with opposite spin, and again, that is your sigma. Can you compare your Lewis structure with your orbital overlapping diagram? They are very similar. It's just you are replacing your Lewis structure with their hybridized orbital and their orbital overlapping. We are basically showing how the sigma bond is formed between the carbon and hydrogen. Easy. Alright? So this is a better version of drawing between your carbon and hydrogen in the shape of tetrahedral, because your carbon right now is a sp3 hybridized orbital. Okay? Overlap end to end with the 1s orbital between the hydrogen to form the sigma bond. Alright, we are forming 4 sigma bond over here. Easy. Simple. Another example, we have PCl5, as always, starting off with your Lewis structure and moving all the way to your geometry. So, from the Lewis structure, looking at the central atom, you have determined the electron domain. The electron domain for your phosphorus in PCl5 is 5. And the type of hybridization because of this electron domain determined is sp3d. And your sp3d is in the geometry of trigonal bipyramidal. Knowing that your trigonal bipyramidal will look something like this. Bear that in mind, this is your trigonal bipyramidal. Okay, you can draw it in many ways of trigonal bipyramidal. You can have your trigonal bipyramidal like this. It's still a trigonal bipyramidal. You can have your trigonal bipyramidal something like this, alright, which is still a trigonal bipyramidal. So it's up to you how you want to draw your trigonal bipyramidal, as long as it is a trigonal bipyramidal. So from that, we can move on to your orbital overlapping of your PCl5, where we were definitely using and starting off with the sp3 hybridized in the geometry of trigonal bipyramidal. So my sp3d in the shape of trigonal bipyramidal shall look something like this. So that is how my sp3d look like in a trigonal bipyramidal. Okay, so make sure you can identify the shape and make sure you can draw the shape out correctly and nicely. Of course, after you have done drawing the shape, don't forget to label them. After you are done, your phosphorus right now will form 5 sigma bond with 5 chlorine. And we know that the valence electron of chlorine is located in 3p orbital. And a p orbital will look something like this. And since they are forming sigma bond means what? Means end-to-end overlapping. So you must make sure your drawing is an end-to-end overlapping with the sp3d hybridized orbital. So let's draw a p orbital over here to overlap end-to-end with the sp3d. And that is my 3p orbital of the chlorine. Okay? And in the overlap area, you will have 2 electrons in the opposite spin that represent sigma bond. It's the same thing. Can you see that? It's the same thing. We are only changing the central atom depending on the structure. Okay, if the structure is a sp3d, it's a trigonal bipyramidal. If just now is a tetrahedral, then the shape must be in the shape of tetrahedral. Okay, and make sure your end-to-end overlapping means they are parallel to each other. They are 180 degrees with the orbital that you want to overlap with. So your p orbital of this shall be something like this in the term of position. Can you see that? They are in a straight line. Okay, that is your end-to-end overlapping. Okay, make sure you label them. That is my 3p of the chlorine, having 2 electrons in the overlap area to form 1 sigma bond. Alright, another sigma with another sp3d hybridized orbital. Just make sure they are end-to-end overlapping. Alright, can you see the straight line? So, when you overlap end-to-end, it must form a straight line. Okay, it must form a straight line. That is the 3p orbital of chlorine. And in the shared region, in the overlap region, you will have 2 electrons in opposite spin, another sigma. The same thing happened for the rest of the hybridized orbital and overlap end-to-end with the p orbital. Okay? And that is how your PCl5 look like in the orbital overlapping. Simple as that. So make sure you know the shape, make sure you can draw the shape, and make sure you label everything correctly. That's it. Okay, that's it. Very simple. But before you reach the orbital overlapping, bear that in mind, you need to get what right? You need to get your total valence electron right. You need to get your Lewis structure correct. You need to be able to determine your electron domain. From the electron domain, you need to know the type of hybridization. From the hybridization, you should definitely know the geometry. And of course, in the orbital overlapping, you must be able to draw the geometry. Okay? So it's just all about the drawing, and everything started back because of Lewis structure. So make sure you get your correct Lewis structure at the beginning of your question. Simple, easy. So this is a better version of your orbital overlapping of your PCl5. You can take a look. on the neat trigonal bipyramidal shape. You can see the trigonal bipyramidal shape. Okay, you can see your 3p hybridized orbital overlap with the sp3d hybridized orbital. Okay, and how many sigma bond that you form, all the label and everything. Next and the last example for this video, SF6. Okay, so as always, start with what? Total valence electron and Lewis structure. So from the Lewis structure, moving to your electron domain, knowing your electron domain is 6, then you will get the type of hybridization which will be sp3d2. Your sp3d2 will then determine the octahedral as the geometry. So right now, you will have your geometry octahedral. Kind reminder, your octahedral looks something like this. Alright, I hope you remember how your geometry look like. So that is how your octahedral look like. Then of course, from that, we can straight away move into your orbital overlapping. So in the orbital overlapping, we will always start off with the central atom sulphur, because sulphur is the one that holding 6 electron domain, sp3d2 hybridized orbital in the shape of octahedral. Always start off with your central atom. Okay, bear that in mind, all the 6 lobes shall be in a similar size because they are the same hybridized orbital. Make sure you label that. So that is the central atom for sulphur. Okay, so I hope you can see the shape of octahedral over there. And then next, your sulphur will form 6 sigma bond with 6 fluorine, knowing that the valence electron of fluorine is 2p. Therefore, you will be drawing a lot of p orbital over here in the orbital overlapping, which is n to n overlapping, because you want to form a sigma bond, so it must be n to n overlapping. Remember, when n to n overlapping, they must be in the straight line with the sp3d hybridized orbital. Okay, so let me show you the formation of each and every sigma bond over here. The 2p orbital of the fluorine. In the overlap area, the same thing, 2 opposite spin electron forming first sigma. Make sure your p orbital must be the straight line with the sp3d2 orbital. So you have your 2p of the fluorine, they are in straight line. Can you see that? 2 electron in the opposite spin in the shared region, your second sigma. So let me finish off that for you. So we are done with the orbital overlapping of your SF6. So you can see over here, that is your octahedral of your sp3d2 hybridized orbital. Each of the sp3d2 hybridized orbital will overlap n to n with a 2p orbital of the fluorine to form 1 sigma bond. So every single one of them will overlap n to n with a 2p orbital of fluorine to form this sigma bond. Okay, and that is how we draw the orbital overlapping. As simple as that. And this is definitely a better version of your SF6 that I can show you. Okay, where the shape is nicely drawn. Okay, alright, but make sure you must be able to draw before your exam. Okay, you must try drawing and you must keep drawing to ensure that you can draw a correct orbital overlapping in a beautiful shape. Okay, and that's it for this video about orbital overlapping. It will be mainly about drawing. I hope you are drawing together with me just now. Alright, make sure you try to draw before your exam. And if you have any question, make sure you drop it in the comment below and I'll get back to you as soon as I can. Remember to subscribe my channel and also like the video and share it to your friend. Thank you for watching and I'll see you again in the next video.